to start, I want to just show kind of the path to solutions, because that's what we do. We deliver solutions to our customers to enable them to do what they want to do. So it starts at the beginning here, and I have kind of this three-pillared approach where it starts and where it ends. So starting at the beginning here, we leverage our own internal tools, our own EDA tools. We like to say we drink our own champagne, if you will. And so I'm going to speak to how we do that here. But then those then are used to generate designs that we then bring over into our cutting-edge hardware and technology platforms. So unlike a lot of other companies out there, Keysight has everything from beginning to end, all the way from design, tools, et cetera, EDA, to enable excellent designs in a quick fashion. And then also all these cutting-edge technology platforms that we're developing in order then to turn those into our customer solutions that address all the market needs for our customers. Some of our solutions here you can see both in signal analysis and signal generation, scope and network analyzer, handhelds, et cetera, but we have a whole plethora of things. So when we talk about how we leverage our own EDA solutions here, there's really 4 ways that we're leveraging them to enable both design success as well as do so in a very expedient and efficient manner. So I'll start here with comprehensive simulation. So we start all the way from beginning with architecture in kind of block diagrams, conceptual, this is how our system's going to look, et cetera. Those get comprehensively simulated, leveraging the system view engine. Then we start filling in the pieces of the puzzle there, and we start generating our signal conditioning components and other things as well, leveraging synthesis with Genesis, and then everything all the way together using ADS, doing all the very comprehensive and very complex analyses and simulations that happen, and then leveraging that over into the 3D environment with EM Pro. And then we don't just do electrical, we look at all aspects of the design. So also as well looking at how thermal plays into it and leveraging the heat wave solution engine as well. And so we have something all the way from beginning the skeleton of the design all the way to the fully fleshed out solution there. Then we take that over as well. So that's great. We have comprehensive simulation, and that's all well and good. How do we also make sure that we're efficient in our path from design inception all the way out to final realization? And also, how do we kind of reinvent the wheel? We have this whole large portfolio of products we've done both in the past, et cetera. How do we ensure that we don't, for example, we save time, we don't do something over again that we've done in the past? So another thing we're doing with the tools is we have this library, this curated design library. Within it contains everything from simple parts, lower level materials, kind of what we call it, mimics and packaged parts, et cetera, all the way up even to parts of subsystems. So this enables us then, when we go and do some more of the design, not only to leverage what we've done in the past, but it makes future solutions and the path to realizing them a lot quicker, a lot more efficient. And so we can in some instances even just put together these blocks that we've leveraged out of our design library and leverage those right over into customer solutions in a very efficient way. At the end, I'll talk more about where that saves us a lot of time in order to expedite our solutions to our customers. As well as, it's all great, we want to make designs, et cetera, be in kind of the design space, but we want to make sure our designs are also manufacturable, and that we can not just make one of these things, but that we can make 100 of them or thousands of them or even more. And we want to see consistently that they're performing as we expect. And so there's a whole nother dimension that often gets disregarded in the beginning from traditional approaches, but we take it into account here, is just making sure that these designs through and through are manufacturable. And so we've then brought in within the tools a lot of checking to make sure they're manufacturable, and we're leveraging a lot of the capabilities of the tools to do so. So we have everything from electrical checks and design checks to manufacturability analysis to see, for example, not only, okay, this is the nominal performance of the solution, but this is the manufacturing window of what we expect to see out of 100 parts coming through here. Gain may be 10, maybe 9 on this one, maybe 11 on this one, etc. Are those within the window that is acceptable for us to deliver this solution? And how that then translates over into the design. So we can do that in the design space leveraging our tools. We also have test coverage checks, because a large part of the manufacturing process is when you get something out on the other end, making sure that it works. And so we want to make sure that not only are we designing products for what we need, but also that it's possible to test them, and assembly rule checks too, which is kind of one level up of the technology platforms. And so then this all gets generated into one nice wrapped up data package. That's the output of the design. And it has everything in there, all the way from the lower level materials and BOMs and test plan and the different artwork for the different designs for the different technology platforms, and it goes into the line. And it's something that then can also be digested by our manufacturing execution system. And so that has everything, like I mentioned, BOMs, test information, et cetera, and then also the MES can take that and we can start generating higher level metrics to look at how efficiently we're putting things through the line, et cetera. So you can see this kind of expands out and starts just giving benefits to all aspects of this flow, okay? So we start then fabricating, leveraging our next generation technology platforms one level up to assembling them into subsystems, testing them, and then delivering them as next generation modules then that get leveraged over. And we're doing this all the way from very low frequency to sub-terahertz now. So you can see it's very challenging. The tools enable that. And so now, kind of going through that, I want to just speak a little bit more to then how these impact our ability to deliver solutions. And specifically, I'm a project manager, and so what I care about at the end of the day is time and dollars. So I'm going to talk a little bit about those. So first of all, holistically, if we think about this then, if we think about the design space, it contains all the physics of the designs we're making. So all the way from kind of the fundamental level of the circuits and the subsystem, the architecture, et cetera, and then filling that out in a 2.5D, 3D, even electrothermal, and then making sure that's manufacturable, and then also the manufacturing window of what we expect to see as we go through these technology platforms, and they have their variations, et cetera. So we have all these pieces, all these dimensions that are interplaying with each other because they all affect each other as well. If you change one thing and that helps the manufacturing window, it might change your electrical performance slightly, or it might change your system performance, et cetera. And so what we need is to kind of close this circle into an overall final solution that we want to realize that then goes out and is a benefit to our customers. And so that's what we're striving to do. And that's where the tools enable us to do that efficiently and quickly, as aforementioned. So what does this mean? Let me also speak where we're going here too with the tool sets as well, with then also making them smarter. So we have the tool sets now, and they're enabling us to go into solutions, but then also we're looking at different things within the tool set to save designer time. And so we're calling this a smart design environment. And it's everything, as mentioned, from the design library to kind of interactive design, maybe leveraging AI, ML, et cetera, the way modeling is done, et cetera, in order to examine kind of all the rote tasks that designers typically have to do to realize these solutions. And remove those so that they can focus more on coming up with innovative new ways of doing things. So what we did is we went through and looked at where our typical designers in our teams are spending their time, and specifically identified in each of these phases how much of those are kind of rote tasks that is something that could be taken care of with this smart design environment. And so in several of these areas, we've identified that about 40% of the designer's time could be addressed, could be automated, could be taken care of in this smart design environment. And so if we look at typical maybe design turns and how many turns we take to get to a product, you know, if each of these takes some amount of time, if we can cut 40% of that out of the equation there, you can see then that this drastically improves our speed at which we can then prototype and get to this kind of final product here. Another aspect of that as well is, like I mentioned, how we're able then to also predict reality with the design tools. And that's that aspect of kind of the comprehensive nature of what they're able to simulate, et cetera. All the way, like I mentioned, from 2.5D, 3D EM to thermal and manufacturing window, et cetera. So capturing all those aspects of the dimensions of the design space and doing so accurately gives you the ability to predict what you're actually going to get, as opposed to kind of going blind into it and then needing another design term. So we have reducing the length of the design turns, and then we also have reducing the number of the design turns. So reducing the number of the design turns is what the comprehensive aspect of the design environment enables, and then reducing the length of each one is what the smart aspect of the design environment enables. So if we look at this and just looking at a typical product, we're going to reduce each design phase by 40%. We're going to drop turns because of the comprehensive nature, simulate what we get what we simulate, and then rolling both of those in, we're not only going to be able to get products out, time to market much quicker and twice as fast, but also we're not going to need to spend as much time and material on doing each of these different design turns, so we can cut those out. So we don't need to buy the material to build up the prototypes and then test them and then do it again and do it a third time. So we can take that out of the equation, and we can just short circuit right to our overall final product here. And you can see that we get massive savings. And this overall not only improves our ability to deliver solutions out, but it also expands the number of solutions that we're able to put out there, and further expands our ability to bring benefit to our customers.